Hello, welcome to another Physical Sciences 3 lecture. And in this lecture, we have an example of a 1.5 kilowatt electric motor is driving a pump which is delivering water to a tank 8 meters above the ground. If the pump and motor and pump are 65% efficient in 45 minutes, how much work is done on the water? Okay, so just talking about efficiency, um, in an ideal case, a motor would be 100% efficient and no energy would be lost to anything. But when we talk about efficiency, or if it implies that energy is lost somewhere. Energy is lost. And it's usually to heat and sound. So if you think about it, a motor will get very hot and is noisy. Okay, so that's why we lose. That's what we talk about with efficiency and is noisy. Okay, so that heat and that noise, the energy has to come from somewhere um, for a motor to get hot and noisy. So that energy is lost in that way, which means that not all of the water goes into, or not all of the energy, sorry, goes into lifting the water up 8 meters. Up 8 meters, okay? So, how much work is done on the water? Because it's only 65% efficient, we have to take that into account. So first of all, um, we know that power is equal to work over time, and we have time and power. So therefore, work is equal to power times time, and we had 1.5 kilowatts, which is equal to 1.5 times 10 to the 3, okay, which is equal to 1500. And time is equal to 45 times by 60, okay? Because that has to be in seconds. Time always has to be in seconds. So that means that we have 1.5 or 1500 times 10, 1500 times 45 times 60, and as you can see, I was practicing earlier, and we get the answer of 4,050,000. Okay, so 4,050,000, which is equal to 4.05 times 10 to the 6. Okay, and that's in joules. So that's how much energy is used by the electric motor in total in 45 minutes, or how much work is used. But what we want is the work done on the water. So work on water, work done on water is equal to 0.65 times 4.05 times 10 to the 6. And if you're wondering where that 0.65 comes from, 65% is equal to 0.65. Okay, so it's the same as 65 divided by 100. I can put that in here in case you haven't seen that before. 65 divided by 100 is equal to 65%, which is equal to 0.65. Okay, and so if we work this out, so let's put that into our calculator. So 4.05, oops, gonna click on there for me. So 4.05 times 10 to the 6 times by 0.65 is equal to 2.63 times 10 to the 6. Okay, you can write the number out in full as well, so you could have written out 2,632,500. You could have written that out in full as well. And it is still in joules. And just a side note, that is equal to 2.63 megajoules. You might have heard of megajoules. We've heard of kilojoules and kilowatts and things like that. If we have a 10 to the 6, the prefix for that is mega. So how much water is then delivered to the tank? We have to consider the work actually done on the water rather than the total amount. So we now remember that work is equal to force times displacement, and force, because it's equal to mass times acceleration, we can work that out. Okay, so we have 2.63 times 10 to the 6 here for our work. Mass, we're not sure how much our mass is. We know that the acceleration that it has to overcome is gravity, so it's 9.81, and it's going to be 8 meters high. So then mass is equal to 2.63 times 10 to the 6 divided by 9.81 times by 8. So let's just put that straight into the calculator. 9.81 times by 8. And it's going to be equal to 2. How many numbers are after the 2? 1, 2, 3, 4, 5, 6. So 2 point. Oh, it's a lot of water. I reckon what's happened is that the I'm going to do this again. So 2.63. I think it's times it by 8 afterwards. It shouldn't be that high. Times 10 to the 6. That's a calculator error. Divided by, I'm going to put brackets around 9.81 times by 8 instead. There we go. That sounds a bit more like it. So it's 33,500 kilograms. Okay. And that's the same. We could, if you feel like it, you can say it's 33.5 tons as well. But kilograms is your standard answer when we're working out these physics problems. Okay. All right, very good. We'll see you in the next lecture.